An air navigation service provider, also known as an ANSP, they are the ones that provide the services that actually manage the airspace. So they're the ones that are managing the air traffic control towers or the TRACON centers. They are providing meteorological information to pilots, and they also are the ones that actually do the physical spacing of the aircraft when they're flying. So they're the ones that make sure that the airplanes don't physically run into each other. Advanced aerial mobility, or AAM, is going to be a challenge for ANSPs because we really have the desire to increase the number of aircraft that are flying as well as the types of aircraft. So these AAM aircraft have different architectures. A lot of them are battery powered or rely on electrical systems. And those batteries represent new constraints to the airspace. We also want to have increased tempo, right? In order to function with an air taxi, you want the service to be available to you. And so in order to have that increased tempo and operational efficiency, ANSPs are going to have to deliver new tools to the operators so that they can function in those ways. ANSPs provide separation services as well as strategic and tactical deconfliction. They also historically provide services like weather updates and resource allocation, so like spacing, landing at a runway or at a heliport. As we look towards the future and what AAM aircraft require, AAM aircraft are going to require new ways to fit more aircraft into the same airspace. So that we need new separation minimum. We also need new tools to help the tactical deconfliction to make sure that these airplanes aren't getting too close to each other, as well as the separation tools that they use on the tactical and the strategic side. So before they actually take off, how can we make sure that we have a schedule that allocates aircraft to the airspace in a way that efficiently uses the airspace? As we increase the number of aircraft in the airspace, we also need to provide more tools to the controllers so they can manage those aircraft efficiently. About 50 or 60 years ago, we created autopilots for pilots so they could manage the cockpit more efficiently and really focus on those time-critical or safety-critical decisions to be made and really reduce the allocation of mundane tasks. We never really applied those same principles in the control tower. We've had very limited rollout of new technologies for controllers to enable them to be more efficient at their job. So what we're looking to do is to create, much like we created the autopilot, didn't replace the pilot, but we created the autopilot, we want to create tools for the controllers that you could think of as like an auto controller, where we're allowing each controller to be more effective at their job and to control the airspace in a more optimized way without putting too much of a burden on them just because we're increasing the number of aircraft. Traditional crewed operations have a pilot in the cockpit, and that pilot is interpreting the data that comes from its instruments as well as what they see outside the window or information that's coming from air traffic controller. Uncrewed systems either have a remote pilot sitting on the ground or a computer that's making the same decisions that the pilot would make, but by interpreting the information that comes into it, not through the eyeballs. So we need to make sure we have new sources of localized data as well as ground control station integration to make sure that the data that the pilot currently uses in the cockpit is available also to the remote pilot or the fully autonomous system. The solutions that SkyGrid is targeting really look at the problem as an airspace integration problem, not just an aircraft problem. So we're really looking at the big picture of how do we integrate multiple types of aircraft into airspace. We do this by delivering high assurance data services as well as air traffic management automation services. One of those services is called GBTS, or ground-based traffic surveillance, where we integrate different data sources of surveillance data in order to deliver the customer a single high assurance track for being able to track their own ship as well as other traffic in an area. SkyGrid system is a single point of truth for all users of the airspace. So we provide that common operating picture to the operators as well as the ANSPs and other users of the airspace. We allow, with that common operating picture, we allow the users to automate certain functions that aren't currently automatable today. So You could think of it as more efficient management of the airspace, because we're allowing ANSPs to control aircraft without direct control over every single aircraft. So they're able to affect the entire airspace at once without having to single out individual aircraft. ANSPs historically have taken a long time. There's a lot of inertia in order to get changes with ANSPs. So we're really starting now by trying to get that momentum into the market and understand really what are the use cases and what are the problems that current ANSPs are having. We also see this as a new opportunity for us to look at new legislation of how third-party service providers and ANSPs can work together in order to deliver new systems and new services to the flying public. So we're really focused on how can we build this today so that it supports the next generation of legislation and it iterates with the ANSP as they grow.